What if you could call remote tools and get back real Python objects instead of raw JSON? We'll see how FastMCP, call tool, transforms simple arguments into fully typed results, automatically unwrapping primitives like integers while preserving complex objects like data types or custom classes. You'll also get both structured data and traditional content blocks in a single response. Async with client. Hash simple tool call. Result equals await client. Call tool add 5b3. Hash result. Call tool result with structured and unstructured data. Hash access structured data. Automatically deserialized. Print result. Data hash 8 int or result 8 for primitive types. Hash access traditional content blocks. Print result. Content 0 text hash 8. Text content. This demonstrates the structured tool invocation pattern, where remote procedures are called as strongly typed operations rather than raw API endpoints. The pattern treats tools as first-class citizens with defined input-output schemas, enabling automatic serialization, validation, and type reconstruction across the network boundary. What distinguishes this approach is its dual-mode result handling, providing both strongly typed objects for programmatic use and raw content blocks for compatibility. The pattern works by establishing a clear contract between client and server through declared schemas, while maintaining backward compatibility with traditional content-based protocols. FastMCP's client automatically handles the complexity of protocol negotiation, schema validation, and object reconstruction, presenting a unified interface whether working with modern typed tools or legacy content-based services. This separation of concerns allows developers to focus on business logic, while the framework manages transport and serialization details. This approach solves the common problem of RPC fragmentation, where different tools require different handling patterns. By standardizing both the invocation mechanism and result processing, it reduces boilerplate for common operations like progress tracking, error handling, and type conversion. The pattern is particularly valuable in heterogeneous systems where you need to integrate modern typed services with legacy content-based APIs, or when building client applications that must handle both structured and unstructured tool outputs consistently. Let's break it down line by line. Async with client. Context manager pattern for async operations. The async with ensures the client connection is properly initialized and cleaned up, preventing resource leaks when the block exits. Hash simple tool call. Result equals await client. Call tool add 5b3. This invokes the add tool remotely through the client, passing arguments as a dictionary. The await handles the async operation, returning a structured call tool result that contains both typed data and traditional content blocks. This pattern keeps tool calls simple while preserving access to both machine-readable and human-readable outputs. Hash result. Call tool result with structured and unstructured data. Hash access structured data. Automatically deserialized. Print result. Data hash 8 int or result 8 for primitive types. This accesses the structured response data automatically deserialized from the tool's output. The framework handles type conversion, returning native Python types like int instead of raw JSON strings. Eliminates manual parsing while preserving the original data structure. Hash access traditional content blocks. Print result. Content 0 text hash 8. Text content. This accesses the raw content blocks from the tool call, providing the unstructured text response. While result data gives you parsed, typed output, result content preserves the original response format, useful for debugging, logging, or when you need the exact string representation. FastMCP tool invocation pattern. The call tool method bridges Python execution and MCP protocol, automatically deserializing structured results while preserving raw content blocks for compatibility. Timeouts and progress handlers must be explicitly configured, as they don't inherit from client defaults unless specified. This dual-access pattern, data vs. content, future-proofs integrations against protocol evolution.
The tool that speaks two languages remains silent in both.